Hi everyone, welcome to our new course, Frozen Foods and Cold Chain Management. My name is Engineer Syed Abdullah, working as Assistant Professor under NPIU at HBTU Kanpur. So this is the lecture one of our new course, Frozen Foods and Cold Chain Management. And the title of this lecture is Introduction and Fundamentals of Freezing. So we will see the outlines. The outlines of this lecture are food freezing, introduction about the freezing, theory of freezing, that means how the freezing takes place, freezing curve, what are the various components of the freezing curve, and how ice crystal formation takes place, and the effect of solute concentration on the formation of the ice crystals, then glass transition, and how what is the role of glass transition temperature in freezing. So these are the various outlines that we are going to cover in this lecture. So we will divide this lecture into two parts. So we will be discussing up to freezing curve in part 1, and the remaining outlines will be discussed in the second part. What is food freezing? So freezing is the unit operation in which the temperature of the food material is reduced below its freezing point and a proportion of the water undergoes changes in state to form ice crystals. So the freezing ultimately involves the reduction of the temperature of the food material to a temperature below its freezing point so that the water present in the food material is get converted into ice. So hereby what we are doing, we are converting the water in present in the food material to ice so that the water is not available for the activity of the microorganisms. That means we are ultimately reducing the water activity of the food material. So the immobilization of water to ice and the resulting concentration of dissolved solutes in unfrozen water lower the water activity of the food, and the preservation can be achieved by combination of low temperatures. We know when we reduce the temperature, the rate of chemical and biochemical reactions inside the food materials decreases to a greater extent, and reduction in water activity, and sometimes pre-treatment such as blanching. So in freezing, the preservation can be achieved by a combination of low temperatures, reduction in water activity, and pre-treatment such as blanching. As we know, blanching is done in case of vegetables to reduce the microbial load as well as to inactivate the enzymes which can cause biochemical changes further during storage of the frozen foods. So by a combination of these three, we can achieve the preservation of the food materials by food freezing, and there will be very small changes to the nutritional or sensory qualities of foods when correct freezing and storage procedures are followed. That means freezing is such unit operation where you can preserve most of the nutritional as well as sensory characteristics of the food material, provided that you have to maintain or you have to follow proper freezing as well as storage procedures. So there are different categories of foods which are commercially available in the market. If you look at fruits, there are strawberries, frozen strawberries, oranges, raspberries, blackcurrants. They can be available in the frozen forms, whole fruit, or in purees, where purees are frozen, or as juice concentration, frozen juice concentrates. Vegetables such as peas, green beans, sweet corn, spinach, sprouts are also available as frozen. In frozen condition, fish fillets like shrimps and crabs, including fish fingers, fish cakes are also prepared, and sometimes fish dishes with accompanying salts are also frozen. Meat products, if you take in the form of carcasses, joints, cubes, and meat products such as sausages, burgers, and reform sticks are also available in the market. In baked goods, bread is frozen bread is available, frozen cakes are available, fruits, meat, and meat pies are available. Prepared foods in pizzas, frozen desserts, ice cream, complete meals, and cooked fish. So there is various category, a wide range of categories of frozen foods available in the market. So rapid increase in sales nowadays. There is a rapid increase in sales of frozen foods in recent year, which is due to the increased ownership of domestic freezers and micro ovens. So nowadays, most of the households contains domestic freezers and micro ovens. So domestic freezers are used to maintain the frozen storage of frozen storage of frozen food materials, and micro ovens are used thawing of frozen foods. So thawing is an important operation in the use of frozen foods, which we will discuss in later course of this uh, later sections of this course. And distributions of frozen foods have relatively high cost due to the need to maintain a constant low temperature. So as we know, during transportation of these frozen foods, we need to maintain low temperatures, and this to maintain these low temperatures around -18 to -20 degrees centigrade, we require the refrigeration system. So that would incur extra cost. And there are various advances are going to reduce the cost during distribution of frozen foods. One of such advances is the use of carbon dioxide snow, which is added to the sealed containers of food. And this carbon dioxide snow, which is also known as dry ice, is added to the sealed containers of food, and which are then loaded into the normal distribution vehicles. So by using carbon dioxide snow, you can achieve maintain the chilled or frozen storage temperatures from 4 to 24 hours by adjusting the concentration of snow. Now, if you look at the theory of the freezing, so what we said, the freezing is the unit operation which involves reduction of temperature of the material to below its freezing point. So to reduce the temperature, first we need to reduce the sensible heat. For suppose the product is at room temperature of 37 degrees centigrade, so we need to reduce the temperature to below freezing point. That means remove of sensible heat. Sometimes along with sensible heat, for fresh products like fruits and vegetables, which respire continuously. So when they respire, there is generation of heat of respiration. So you have to consider this heat of respiration while removing sensible heat. So that term used to represent the sensible heat and heat of respiration is heat load. So and it is important in determining the correct size of physical equipment for a particular production rate. So we know most of the food materials contain large amounts of water, and this water has a high specific heat. Specific heat, you know that specific heat is the amount of heat is required to raise the temperature of 1 kg of product through 1 degree centigrade, right? So it has high specific heat of 4.2 kilojoule per kg Kelvin, and high latent heat of crystallization. So when water is converted into ice, there is generation of heat of crystallization, which is around 335 kilojoule per kg. So a substantial amount of energy is therefore needed to remove the latent heat, form ice crystals, and hence to freeze food products. The latent heat of other components also need to be considered. If you look, other components present in the food materials are vitamins, minerals, fats, proteins, and carbohydrates other than water. And but the removal of relatively small amount of heat is needed for crystallization of these products to take place. Look at the various water freezing points of different foods and their water contents. So vegetables having a water content around 78 to 92, their freezing point would fall in the range of minus zero point -0.8 to minus 2.8. If you look at meat having a moisture content 55 to have a low freezing point, that is minus 1.2 to minus 2.2, than your vegetables. Similarly, egg having a moisture content around 70% have a freezing point of minus zero point -5 degree centigrade. Here C to D also there will be increase in the temperature. At D to E, crystallization of water and solution. There are two crystallization taking place, water and solution continues. The total time taken is determined by the rate at which heat is removed. So here till now the time taken to froze food material depends upon the rate of heat transfer only. The temperature, now we'll see EF, the end part. So here at the end of the E, or at the starting of the E, the freezing, that is conversion of water to ice, takes place, is completed. That means further you cannot convert the water into ice because of the temperatures used in the commercial freezing. So the temperature of the ice water mixture falls to the temperature of the freezer. So here the temperature of the product reaches the temperature of the freezer, whatever the medium is used. A proportion of the water remains unfrozen at the temperatures used in commercial freezing. The amount depends on the type and composition of food and the temperature of storage. So, for example, in lamb you can froze only 88% at minus 20 degrees centigrade, 91% in fish, and 93% in egg albumin. So there is always some unfrozen liquor present, remains in the frozen food material because of the mm, commercial temperatures used, because of the freezing temperatures used in commercial freezing. So we cannot go up to the effective temperature of the solute so that we can completely froze the food material, why we will see in the upcoming